Friends, welcome to Biology Made Easy. Today in this video, we are going to discuss one of the again very important topics in the environmental issues, that is ozone depletion in the stratosphere. So, as you know that the Earth is surrounded by the first layer of atmosphere. This is known as troposphere. Then the troposphere is followed by stratosphere. This is the troposphere and this is stratosphere. So both in the troposphere and stratosphere ozone is present, but in the troposphere only 10% of the ozone is present, while 90% of the ozone is present in case of stratosphere. That means it forms a covering. It forms a covering around the Earth, and this is also known as ozonosphere. Ozonosphere. Now, the 10% of the ozone that is present in case of troposphere, this is also known as bad ozone. This is in the troposphere, it is known as bad ozone because it causes a lot of harm to the human beings, the plants, animals. That is why it is known as, it causes mutation, skin cancer, all those things. That is why it is known as bad ozone. But the 90% which is present in the stratosphere in the form of a shield around the Earth, this is known as good ozone. Good ozone. Now, this ozonosphere, this is present, if this is the equator, above the equator, it is present around 25 kilometers above the equator. While in the poles it is around 16 kilometers. That means in the poles it is above 16 kilometers, while in the equatorial zone it is above 25 kilometers. Now, if we come to the concentration of this ozone, then in the stratosphere the concentration is 0.03 ppm, or we can call it as 0.03 ppm or 300 Dapson units. Dapson units, because ozone is usually it is measured in the form of a Dapson unit. So 0.3 ppm or 300 Dapson units, while in the troposphere the bad ozone, it is around 0.05 ppm or 50 Dapson units. That means it is present very less. Again, you will come to the thickness of the ozone. In the equatorial zone, it is a 0.29 centimeter in the equatorial zone, while in the polar zone it is around 0.4 centimeter. That means in the polar zone it is slightly thick, and in the equatorial zone it is slightly thin. Now, this ozone layer which is present in the stratosphere, its concentration is almost maintained, its equilibrium is maintained because it is continuously formed and again continuously photooxidized due to presence of the UV rays coming from the sun. From the sun, the UV rays coming, and in that UV rays, what happens? This is convert the ozone. It is converted to oxygen and nascent oxygen. So it takes place only in the presence of UV light. That means the ozone breaks to oxygen and nascent oxygen, and both of them combine. That means always an equilibrium is maintained. So because this equilibrium is maintained, that is why it forms a shield, a covering around the earth. That is why the UV rays is directly not coming to the earth and we are protected. So this is known as the ozone sphere is known as a shield for the earth. Now it has been seen that in the ozone layer the thickness is gradually decreasing, and at some places, particularly above the Antarctica, there are certain holes have been created which is known as ozone holes. Ozone holes. Now why these ozone holes have been created? It is because of the depletion of the ozone. If you will mark, that is during 1970, in the polar area, there was around 375 Dupson units are there, and during 1986, 136, while in 1994, only 94 Dupson units of ozone are there. That is, in this way, the thickness of the ozone layer is decreasing. So when ozone layer will decrease, naturally the UV rays will directly fall on the earth's surface. Now the question is, why there is a depletion in the ozone layer? What is the cause behind it? So the main cause behind it is the chlorofluorocarbon, then the nitrogen oxides, and also sulfur oxide. Other things are there, but the major problem lies with the that which we will discuss the cause of depletion. So the major contributing factor for the depletion of this ozone is the chlorofluorocarbons, and it contributes to 14% of depletion. 14% of depletion, while the nitrogen oxides, they contribute to only 3.5% of depletion. That is a major is this chlorofluorocarbons. So where from these chlorofluorocarbons are coming? Where from is coming? What is the source of this chlorofluorocarbon? Now number one is the jet planes. The jet planes, they use the chlorofluorocarbon in their fuel, so that comes. Then this launching of rockets, so that also gives rise to chlorofluorocarbon. Besides this, then the chlorofluorocarbon is used in air conditioners, then refrigeration, also fire extinguisher, and also it is used in plastic foams. So from all these sources, the chlorofluorocarbon is liberated, and mostly it is liberated from the developed countries, the industrial countries like European countries, North America, Japan, Russia. They use more of these things. That is why the chlorofluorocarbon is liberated from the different industries and all these machineries. And this chlorofluorocarbon from the troposphere, it moves to the stratosphere, and in the winds, it moves towards the Antarctic poles. Now when it moves through wind towards the Antarctic pole, during winter season, since the temperature is very less, these chlorofluorocarbons, they cannot do any harm, because the chlorine atoms which are formed from this chlorofluorocarbon, that will give rise to only ice blocks. That means how this is functioning. The chlorofluorocarbons, that is, we can write CFCl3. Now this CFCl3, it will break into CFCl2 plus chlorine. Then this CFCl2 will again break to CFCl and again chlorine. Now this chlorine will combine with oxygen and it will give rise to the chlorine oxide and also oxygen. Now this ClO will again combine with oxygen and it will give rise to 2 molecules of oxygen and 1 molecule of chlorine. That means the chlorofluorocarbons, it gives rise to chlorine. And this chlorine, 1 molecule of chlorine can break 1 lakh of ozones. That means 1 molecule of chlorine can break 1 lakh molecules of ozone. And this chlorine atom, during the winter season, it is present along with the ice blocks. And during this time also there is no sunlight in the Antarctic area. But in Antarctic area, when the spring comes, there is sunlight. In the presence of sunlight, this chlorine molecule combines with oxygen and it is gives rise to oxygen, so that the amount of ozone is depleted. And because the thickness of the ozone is depleted, it is known as ozone hole. So when there is an ozone hole and there is a depletion of this ozone, naturally there are several dangers to the earth. So what are the harm that will be caused when this ozone is depleted? So what are the effects of the ozone depletion? Now usually from the sun, the UV rays which is coming, it usually ranges from 100 to 390 nanometer. Now from 100 to 280, this is known as UVC, and this is usually absorbed by the atmosphere. Then from 280 to 320, this is known as UVB. This is very harmful. And from 320 to 390, it is known as UVA, and it is not harmful. We can write harmless. It's harmless. That means from these 3 types, it is only UVB which is very much harmful. So when this layer of ozone is depleted, the UVB ranging from this 280 to 320 wavelength, that directly falls on this earth surface. So what it causes? The number 1 is the cornea. The cornea of the eye is very much affected and leading to, we can tell it is that it's snow blindness. Snow blindness, cataract. This is one of the very important. Number 2, it also leads to blindness in most animals including human beings. Most of them will be blind when UV light will fall. The third one is on skin. In case of skin, usually there is aging of skin, then several skin diseases, then also there is a skin cancer. Then the third one is usually it causes mutations in DNA, leading to so many breakages and so many harms caused to all animals, including human beings. Then it also causes in human beings herpes and decrease in immunity. Then another point is it inhibits photosynthesis. Inhibits photosynthesis. So when photosynthesis is inhibited, the carbon dioxide concentration will increase and it will lead to global warming. Now besides this, it also leads to infant mortality. Infant mortality. That means when ozone layer is depleted, these are the different types of that is the diseases, or it will affect all types of animals, including human beings and as well as plants. That means it becomes a danger to the living society. So, what to do? To check this depletion of ozone, the international organizations, they have taken some steps. So we have to discuss what are the different steps they have taken, the international initiatives. So the international initiatives are to check the depletion of ozone. So number one is Montreal Protocol. It was in 1987, though it started functioning in 1989. Started functioning from 1989. So the Montreal is one of the cities in Canada. So in this, what was the discussion? Now, all the industrial countries, they agreed to decrease CFC use. That means the amount of CFC they were using, how that can be decreased. So that was discussed in the Montreal Protocol. Then the second one is Helsinki Declaration, and this was in 1989. So in this, nearly 82 countries, they ratified this Montreal Protocol. That is, more countries added to it. So they ratified Montreal Protocol. Then the third one is Earth Summit. Earth Summit, it took place in 1992 in Rio de Janeiro, and it is in Brazil. So in this, what is the achievement? There should be reduction in the greenhouse gases. Reduction in greenhouse gases. Then the next one is the Kyoto Protocol. It was in 1997, and in this case also the discussion was how to reduce greenhouse gases, GHG, greenhouse gases, how to reduce the greenhouse gases. And again in the Beijing Protocol, it was in 1999, and here also how to reduce the chlorofluorocarbons. That means these are the different international initiatives how to check the different greenhouse gases, because chlorofluorocarbon is also a greenhouse gas, and also particularly for ozone, how this CFC can be, its use should be decreased So these are the different international initiatives, and these are also very important for examination point of view. Now let us discuss some questions. So, so one question you can write, which of the following protocols did aim reducing emission of chlorofluorocarbons in the atmosphere. So the one choice is Geneva Protocol. The second one is Montreal Protocol. The third one is Kyoto Protocol, and the fourth one is Gothenburg Protocol. Now, second question. The second question is depletion of which gas in the atmosphere can be used to an increase of skin cancers. So the one choice is ozone, second choice is ammonia, the third choice is methane, and the fourth choice is nitrous oxide. Now this question was asked in NEET 2016, and the first question it was asked in NEET 2019. That both the questions are very recent questions. So from the discussion you can get both these questions. So now I hope you have a very clear idea what is ozone, what is its importance, what is bad ozone, what is good ozone, and what is main role, how it functions like a shield around the earth, and what is the cause of depletion, and if it is depleted, what are the different bad effects on the living organism, including both plants and animals. So thank you very much. God bless you. Wish a very bright future.